Hello everyone. This video is talk about homework 4 problem 2. So based on the condition, we know that the random variable of x is uniform. So that based on the definition of the uniform function, we will have it's uniform from -1 to 1. Then we plot like this way. And the value here, based on the definition of the uniform, and we have the function as. Here we have the boundary for 1 minus -1 to, or 1 over 1 minus -1, and that will be 1 over 2, and this from -1 to 1 and 0 for otherwise. And we know the the continuous density function of big Fx it from before -1 it is 0, and from -1 to 1 it reaches to 1 with the function as 1 plus x over 2, and then become 1 after 1. So we get the CDF as this way. So we majorly talk about what's Fy will happen. Talk about all the or what happened between -1 to 1, and then from the condition we know that small Fy is equals to 2 times e to the power of -2 times y, and times the unit step of y. So if we would like to find the y equals to gx, we need to find, we can set the CDF of Fy is equals to the CDF of Fx. Then to get this one, we will integrate it and it equals to 1 minus e to the power of -2y. And then this one equals to Fx s, which we had before as 1 plus x to the power of over 2. And after we solve it, we will have y equals to -1 over 2 and ln 1 minus x over 2. And this one is gx. So this one is what will happen on x from -1 to 1. Since we know that x will comes to 0 after when PDF of fx is equals to 0 when x is less than equal to -1. So the y equals to gx is equals to 0 when x is is less than or equals to -1. So when x is larger than or equals to 0, the y equals to gx will always getting closer to the infinity. So now finally we can have the set function, the important function as gx equals to 0 when x less equals to -1 and -1 over 2 when 1 minus x over 2 when x in -1 to 1 and infinity for otherwise.